What's going on, guys? It is Tuesday, May 5th, and today we are going to start 2.5. 2.5, let's see what it deals with. We talk about similar figures, which are figures that have the same shape, but not necessarily the same size, are called similar figures. All right, so two figures are similar when corresponding side lengths are proportional and corresponding angles are congruent. All right, so everything that we've talked about so far in this chapter, we've been talking about congruent figures where their side lengths and their angles are the same. Now we're talking about figures where their angles are the same, but their side lengths might be different. Okay, but those side lengths must be proportional, which we've actually talked about in a previous chapter. All right, so let's real quick just go over what does it mean for side lengths to be proportional, or what is a proportion. So if we just look at numbers 1 and 2, real quick, brief example. If we wanted to tell if these fractions are proportional, we're seeing are they the same fraction when we simplify them, okay? So 2/5 we can't simplify, but 10/25, if we take that and divide both the top and the bottom, the numerator and denominator, by 5, we get 2/5. So those are proportional fractions, okay? If we look at number 2, 7/14, that's really 1/2. 21/28, that's really 3/4. Okay, if we simplified those fractions. So they are not proportional. Okay, so that's what it means for two fractions to be proportional. So your first goal is to see which rectangle is similar to rectangle A. We're going to identify or determine if two things are similar or not. All right, so if we're looking at rectangle A in regards to rectangle B first, what we're going to do is we're going to write fractions, or we're going to make fractions out of corresponding side lengths. All right, so what they did here was they said the length of rectangle A is 6, as well as the length of rectangle B is 6. So 6/6, that equals 1. Now we're seeing, is that the same as the ratio that we can make out of their widths? The width of rectangle A is 3, and the width of rectangle B is 2. 3/2 is not the same as 6/6 or 1, so they are not proportional. Now, if we're looking at rectangle A to rectangle C, our length is 6/4, which simplifies to 3/2. Our width is 3/2, which is already simplified. So those are the same fraction, meaning that rectangle A and rectangle C are the ones that are proportional. All right, so that's going to meet your first learning target. Now the second learning target is that we're going to be able to, knowing that we have two similar figures, we're going to find a missing side length. All right, we're going to do that by, first we're going to write a fraction out of the side lengths, or the corresponding side lengths that we know. So I know that this side is 6 and this side is 9. Those are corresponding side lengths. So I'm going to use that as like a base fraction. Now I'm going to write a fraction of 6/9 equals, I'm going to write a proportion, equals, this side length is 8, going from the smaller triangle to the larger. This triangle, I don't know that side length, okay? But I can find it using a proportion. Because I know they're similar, I can write a proportion and solve for the missing side length, okay? Now remember, I can do this by cross multiplying. All right, so 6 times x is 6x equals 9 times 8, 72. And now I'm just going to solve this equation. Divide 6 and divide 6 to find my x value. Okay, so that's the same thing that the book does. Let me erase all this. We can read this together. So Because the triangles are similar, corresponding side lengths are proportional. So write and solve a proportion to find x. So that's what we did. We took the corresponding side lengths that we knew to write a base fraction of 6/9, and we set it equal to the side length that I knew and the one that I was missing. Okay, 8/x. When I cross multiplied, I got 6x equals 72, and then I can divide each side by 6 to get 12. So x is 12 meters. All right. All right, so let's do that same thing with this example. Okay, so I'm going to look for the corresponding side lengths. Okay, 4 and 6 are corresponding side lengths that I know both of them. All right, so I'm going to write a fraction, a base fraction, using those corresponding side lengths of 4/6. Okay, now I'm going smaller to larger, so I'm going to go 8/x. All right, and I could cross multiply, right? I could cross multiply and solve this, but hopefully you're noticing. Remember, these have to be equivalent fractions. To get from 4 to 8, I'm just multiplying 2, right? This is times 2. So couldn't I do the same thing here and find x? Yes. So times 2 is going to give me what x equals, which would be x equals 12. Okay, so there's kind of what you should be noticing is there's kind of multiple ways of doing these problems, but that's essentially it. So let's look at one more. Okay, if we look at example 3, it's just basically a word problem using the same skills. All right, so it says an artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica is 3.75 inches. What is the height of the trapezoid in the replica? All right, so I'm looking at these two shapes and I'm seeing that I know these sides. All right, I know these sides. So I'm going to make a fraction out of them, which is, I believe, what the book does as well. Okay, so that's what they did here. They made a fraction, and they're going from the replica to the painting. Okay, so they made a fraction out of the corresponding side lengths of 3.75 over 15. Okay, and now we know the height of the painting, but we don't know the replica. All right, so they went h/12. They wrote a proportion, and then they are basically solving that proportion to get that h would equal 3. Okay, so same concept as the last problem. Like I said, that's pretty much it for the lesson. Okay, so now what you guys are going to do is go into big ideas and complete the 2.5 practice. It's just a couple problems to make sure that you understand this. And again, hopefully this made sense. If you have questions, email me, or you can ask questions in the discussion thread on Canvas. But otherwise, I will talk to you guys tomorrow.